Hi, in preceding sessions we have learned about current and voltage. Today we will be discussing about how current in a conductor depends on its resistance. Resistance may sound negative, but in electricity it can be used beneficially.
Let us start by understanding the concept of power and resistance. These are the topics will be covered during this session. Define electric power, what affects the flow of current, define and explain resistance. So what is electrical power? You have studied that the rate of doing work is power. This is also the rate of consumption of energy. So electrical power is nothing but the rate at which an electrical appliances use electrical energy. So what is the expression for power? Power is equal to current into voltage. Power is measured in watts or kilowatts. Current is measured in ampere and voltage is measured in volts. The unit watt is very small. So in actual practice, we use a much large unit called kilowatt. So we have learned now, power is the product of current and the voltage. There is an easy method for remembering this formula. We call it as formula triangle. What is that? A formula triangle helps you to rearrange a formula. So the formula triangle is shown here. So if you want to calculate I, so you have to cover up that quantity, and to find current I, which gives the formula I is equal to P divided by V. Similarly, if you want to calculate voltage, it is nothing but P divided by I. So what is power then? Power is P is equal to I into V. What affects the flow of current? How do different components in a circuit affect the flow of current? Current is flowing in a circuit is different for different components. Why do they differ? Because certain components offer easy paths for the flow of current, while the other resist the flow of current. So what affects the size of the current? Current can be varied by increasing or decreasing the voltage of the circuit. Components in a circuit may reduce the size of the current. This is called resistance. All wires and components resist current. Resistance is a measure of how hard it is for electrons to move in an electrical circuit. So what is a resistance? We know that the motion of an electron in an electric circuit constitutes an electric current. The electrons are not completely free to move within a conductor. They keep on colliding with the atoms in the conductor. Thus, the motion of electrons through a conductor is retarded by its resistance, which is similar to friction, which opposes the motion. So resistance can be defined as the opposition offered by the conductor to the flow of electric current through it. A component of a given size that offers a low resistance is a good conductor. An insulator of the same size offers even higher resistance. Do these materials have high or low resistance? It has high, low, and high. So insulators offers high resistance and conductors offers low resistance. That means good conductors of electricity have low resistance and poor conductors of electricity have high resistance. For example, nichrome wire have a higher resistance than copper wires. So, should we use nichrome or copper to make wires? What is the answer? Melting point for a nichrome wire is greater than copper wire. So that the resistance at nichrome wire will be greater than copper wire. Therefore, the electric current can flow on nichrome wire will be smaller than the copper wire. So nichrome wire is used for electrical heater element because it has high resistivity and high melting point. What you have learned? Resistance is a property that resists the flow of electrons in a conductor.